So if you take the path tool up at the top, yeah, and then
Yeah.
click on the west side of the Atlantic, right?
Uh,
So all the way over to the edge of the continent.
oh, sorry. So like here.
Yeah, and then go all the way to Africa. What in a straight line? Yeah.
I don't know why this happens. Yeah, I did that. And
Yeah, let me see the profile that you get out of that.
yeah, okay. It's like 0.
This is a glitch that keeps happening.
Oh, is it?
Yeah, try drawing in a different place. Yeah, okay, let's see.
Oh, sorry. I tried in many places, like
Right click on that line and show the profile again, the same one. I want to see if you can stretch the box, the profile.
it's not clicking. Oh,
You press control click as well. Okay, pull the box up further, like stretch it vertically. Yeah, it's really not, is it?
no.
So one other student has complained about this, and this happened to me one time. I suggest quitting Google Earth and reopening it and trying again.
I did that. I did that. It didn't work.
All I can suggest is keep trying because you're doing it correctly. It's
Okay.
a glitch in Google Earth. If you can't get it to work, I'll send you a profile to use.
Okay. Yeah, see?
That's terrible. Okay, let me email you a profile, okay?
Yeah.
What happens if you do, have you gotten to the end of that lab yet?
No, I haven't yet.
Okay, because it's going to ask you to do an even larger profile a longer profile from Africa, across the Atlantic, across South America, and into the middle of the Pacific. So maybe I'll send you 2 profiles that you can use.
Okay, yeah, that would be very helpful because I tried. I even got like really close, zoomed in, and did it in one of the trenches, and
Yeah,
then it
still
didn't
did not.
work.
So I should write to Google people.
Yeah, and then I tried like here.
Yeah, I'm not surprised. It keeps happening.
Oh, Olivia?
Oh, you got something. Oh, you got something.
Nice.
Okay, it's kind of, I mean, it's all squished, but if you can stretch it like horizontally, that would help to see the whole point is that you see the deepest parts of the ocean are not in the middle, that like there's the ridge is there. It forms a mountain in the bottom of the, oh, so the west side didn't work, just the east.
No, yeah. So that didn't work. I think this. So this is like a. So this is a ridge.
So you're seeing, well, you can see on the line, you see the mid-ocean ridge, right? Go to the left, left. Oh, no, you went too far. Go right to where that bar stops. Yeah, okay.
Okay.
And then look at where your pointer is on the profile.
Yeah, I
So
see that.
you're just coming up to the ridge and then the glitch happens. So
Yeah.
keep going. It would look like a slightly bigger mountain there if it hadn't done that. Maybe try a few more times and see if you can get it to show you the entire length.
Okay, I'll try that.
Now that you've seen it works in one place, or at least partially works.
Yeah, I was just so confused. I was like, This is not working. What's happening? I can't see anything.
Yeah, no, you were absolutely right. It's Google. In fact,
Yeah.
I think I'm gonna send a message to the whole class about this.
Okay, yeah. So it's not, I don't think it's working in like south or west.
Oh, oh, I see. Did you get it? Try in the North Atlantic then.
Okay.
Let's see if the North Atlantic maybe is better. So go from Eastern US to Africa there, like
Yeah.
Morocco, and see.
Wait. There we go. Sorry.
No, no problem.
Oh my god. Just
Does it keep spinning on you?
yeah. So okay, I'll try that. If
One, I
it
really hope
works.
it works. Okay, I'm gonna cross fingers.
Wait,
Oh, Google, you can do it.
sorry. I'm gonna delete. I have to zoom out.
Yeah, that's okay.
So this is south. Oh wait.
You can
So
pick
from
anywhere
here.
across the middle of the Atlantic. Yeah.
Yeah. Okay. And then
Um,
oh, it works.
Woohoo! Oh, yeah, great.
Okay.
Yay,
So
you got it.
so there's like a this here, and then there's like a
Uh,
spike, and then
yeah,
it doesn't.
wait, what happened? It looked better before a second.
I don't know.
Oh my God. Okay. Well, you have half of it. So just work with half a profile if you can't get the entire length. As long as you
Yeah,
can get from the edge of the continent to the mid-ocean ridge. Oh, look at that. It changed again.
it's changing.
It's changing.
Yeah.
How bizarre. So wait a minute. What are you doing there to in between? Did you close it and then open it again?
Yeah, I just show elevation profile, and then this is so weird.
Oh my God. Okay, I'm gonna write to the Google people and tell them they've got a problem here. Um,
Yeah, it's not responding
okay,
now.
just hang in there. I will send you a profile to use if it doesn't work, but
Okay,
hopefully before by the time you get it, you will have like your own profile done.
okay, okay. Thank you. That's
You,
all I needed to ask,
okay.
because I didn't do anything because I was so frustrated by this. I was like, why is this not working?
Yeah, yeah, yeah.
Oh,
I'm
it's
sorry about that.
your fault.
Okay. Well, I'm glad we've sorted out the problem at least. But
Yeah.
look for an email from me and let me know if this becomes a problem when you do the even. It's question 29 asks you to do a much longer profile. So
Okay.
I can send you that one as well if necessary.
Okay.
Okay?
Okay. Thank you. Thank you so much.
You're welcome. Good luck.
Yeah. Okay. I'm gonna go now.
Okay,
Bye.
bye.
Hello.
Oh, hey, didn't see you join.
Oh, really? I've just been kind of here.
What's
Just
up?
needed a few questions.
Okay.
Let me find some. Oh, um, off topic, but I think I'm gonna need help for the last one because don't
Which
really understand
talking
the
about?
instructions. Hmm?
Which one are you talking about?
Sketch a north-facing cross-section, like the final question of the whole
29?
lab. Yeah,
Yeah, okay, no problem.
for
Um,
sure.
I left some instructions, by the way, just FYI.
Mhm.
Someone's already asked this question and I posted like some help in the, here, I'll show you. I posted help in the Q&A forum.
Mhm.
So like it's here. So if like there isn't a Zoom session available, try looking in the Q&A forum here because I did this question 29, location of the profile. And somebody asked, they said, okay, is this the right place? And I said, okay, no, that's not at 10 South. It's too far south. And
Okay.
this profile goes the wrong direction from Africa. This is going from the African continent across the Indian Ocean, Australia, and into the Pacific. You want to go the other direction. So you're going to be creating a profile that starts in Africa, goes west and crosses the Atlantic, crosses South America, and goes into the middle of the Pacific.
Okay.
So I can show you that also.
Yes, please, because
I need a second just to get my Google Earth working,
Mhm.
or started anyway.
But yeah, I've also been having Google Earth troubles. It's really bad.
What
I'll try
struggle?
to open it.
What's the problem?
Sometimes when I try to open it, it says it's not responding.
Oh, that's
Um,
your internet.
okay. And then what's it called? Yeah, I had the same problem with the pathway when you would make one and then it wouldn't display any um elevation differences. It would just be
Yeah,
flat.
that is a Google glitch. And
Yeah.
did you finally get it to work?
Yeah, I tried. I thought it was too short of a distance maybe, so I found a longer uh
Yeah,
distance in between and worked.
that wasn't your fault. It's a glitch in Google. There have been at least 2 other students have had the same problem. Sorry, my Google it takes a while when I'm on a Zoom call at the same time.
Oh yeah, that's fine.
But if I can kind of guide you on yours, if you've got it going, what you want to do
Yeah.
is, first of all, find the equator, find Africa and the equator. And then you're going to move your pointer south from the equator to 10 degrees south. And the latitude and longitude are displayed at the bottom of the Google Earth window. So you can see when you get to 10 degrees south. And probably zoom out on Google Earth to do this so that you can see, and then orient your globe so that you can see Africa, South America, and the Pacific. And then draw a line all the way from the African continent across the Atlantic, across South America, and into the middle of the Pacific.
Okay, here.
That's what that question is asking you. Okay,
Can you see?
finally, I've got Google Earth going. Okay. Here, I'll show you this. Okay. So, I've got my profiles left over. I was experimenting with this because these guys are or Google was, like you said, giving flat profiles. Okay, so we want to find, let me get rid of this one too. Delete. Yes. Okay. So I'm going to zoom out a little bit.
Oh, do you want me to share my screen? I mean, stop.
Oh, can you see my screen?
No, because I'm sharing mine.
Oh,
Here, I'll stop mine. Okay, there we
okay.
go.
Okay. Now can you see mine?
Mhm.
Okay, good. All right, so equator. So look down here at the bottom of the screen for the latitude and longitude. I'm going to find the equator in Africa first. So see, it says like 12 degrees, 11 degrees north there.
Mhm.
So I'm going south. Okay, the equator is about here. Just a little further. Okay, right there. It switches from north to south. So that must be Equatorial Guinea right there. Okay, so you're gonna, the question specifically asks, wait, I gotta open this just to check the wording to make sure I'm doing this right for you. It says to go from just from Africa. Okay. So you need to start there. We're going to go south 10 degrees. There's 10 degrees south latitude. Okay. So that's the position that we want to tend. So we want to draw a line from Africa across the Atlantic, across South America into the Pacific. So I'm going to zoom out a little bit and then take my path tool and go from Africa to here. Am I at 10 degrees? 17 south. I'm a little bit far south, but let's see if this works anyway.
Okay.
Oh, shoot, I got rid of it. I meant to click on it. Oh, well, let me try to find 10 south. There's 10 south. You know, this is approximate, right? So it doesn't have to be perfect. That's close. And this is, I lost my way, 10 south. Okay. So it should be about horizontal, about at the same latitude. And then let me just say, okay. And I'm gonna show elevation, cross fingers, yay. Okay, so it worked this time. But this is what the goal of that exercise was to do.
Okay, so just that, and then I sketch it.
Well, I mean, you're using the profile. Do you need to sketch it too for that question?
Because it says sketch a north-facing cross-section. Oh, is it just telling you the instruction? Oh. Is that what it means?
Let me just say, oh, it does say sketch. Okay. Okay. Well, you can see the profile by doing this in Google, right? So you can get an idea. It looks like it went flat in the oceans again. Shoot.
Yeah.
That's really a pity. So I'm going to have to try it again. Or you can also just use this line and do an approximation of what the profile would look like. Because if you've done the rest of the lab, you should have an idea kind of what the topography would look like.
Yeah.
Do you?
Yeah, I've done.
Yeah, so you can, you see that the continent drops off pretty quickly. You get to the deep part of the ocean, like right there, and then you've got to go up the mid-ocean ridge, that mountain in the ocean basin. You're going to get deeper again and then come up to the continent, which is going to sit up really high compared to the ocean floor. You've got some mountains that you've got to represent on the continent. You've got a deep ocean trench right there.
Yeah.
And then your seafloor should be pretty deep here and then get shallower toward the mid-ocean ridge again.
Yeah.
That's the goal of the exercise, is to be able to represent all of those things.
Okay.
Okay, so yeah, I don't think you actually, if you can get your profile to work on Google Earth, then great, and you can use that as a guide for your sketch. But you can also just do this based on your learning.
Yeah, approximation. Okay.
Yeah, okay.
And then I was wondering if you could maybe go over with some of the questions. Not like, I guess just tell me if I'm doing things right.
Okay, sure. What?
Just kind of want to double check. Just the majority, not really the sketches.
Okay.
Just some of the questions.
Like what?
Let me see. Oh, give the locations of 3 other ocean trenches. I gave them in the coordinates, like the latitude and longitude, if that's okay.
You should also describe the place.
Okay.
So that I know where those are, what you're talking about.
All right.
I mean, I can go find the lat longs, but it will help me if you can explain like where those trenches are.
Okay, so like in between this and this, in the middle of this.
Yeah,
right?
The trench between the Nazca plate and the South American plate, for example.
Okay. All right. Oh, the earthquake ones.
Okay. Which question is that? number, please, just so that I can.
8.
8. Okay. Oops. 8. Okay, describe any patterns you see in the distribution of earthquake epicenters over Earth's surface. Do they form lines, arcs, circles, or clusters? Are patterns connected or disconnected? Okay, so here you're really just describing what you see. So you should, for instance, you should see a pattern of earthquakes around the edge of the Pacific Ocean.
Yeah.
that go kind of along the ocean continent. It's like along the continental margin,
Mhm.
right? That's a pattern.
Yeah.
So that's something that you could describe.
Should I describe them as arcs? Because I think the part that got me was, do they form lines, arcs, circles, or clusters?
Yeah. So don't fret too much over this, right? This is just
Okay.
it's a finer point. When you represent a line on a spherical surface, they become an arc. So if you subduct the Pacific plate beneath the Asian plate, for example, it might happen in a line, but you put that on a spherical surface and it becomes a curved, like, arc shape. That's what
Oh
this is
yeah. Mhm.
talking about. So maybe I can, let me share my screen again and I can describe a little bit better what I'm talking about. Okay, so do you see the Marianas Trench right there? How
Yeah.
it's arcuate. It's an arcuate shape. This trench here along the Japanese islands and that chain of volcanoes, it's an arcuate shape also. This is an arc. Do you see what I'm saying?
Yeah.
But you could also describe them as being kind of in a line along the volcanoes. So it's, don't worry about which word you choose as long as you're consistent with your description.
Okay. And then for 10.
10. Okay. Look closely at and around Earth's ridges and trenches. The earthquake depth patterns associated with these features are different. Okay, so in the vicinity of the ridges and
Um,
the trenches. Okay. So it's talking about the mid-ocean ridges and it's talking about the deep trenches that form at subduction zones.
yeah.
Right.
I don't know how to describe whether it's symmetric or asymmetric, the distribution.
Well, what
Do
do
I
you
use profiles or?
so let me turn on the earthquakes. Where are my earth? Oh, there they are. Okay, so let's turn on the large ones. Oops, there we go. Maybe we need the medium ones too. Actually, I'm going to turn them all on because I want you to see the mid-ocean ridges. Okay, actually, those don't show up well. The seismicity along the mid-ocean ridges doesn't display terribly well here.
Okay.
So that's going to be difficult to see, but yeah, I think we need to zoom in to see these patterns. Let me just, I gotta get this to the north again. Okay. Okay, so the Gulf of California is opening up a small ocean basin, basically. And so
Okay.
that is representative of a mid-ocean ridge. This is a mid-ocean ridge that we see separating the Pacific from the Nazca Plate. So they're all orange. So that means they're all shallow. And
Yeah.
that's different from over here at the trench where you see all of the colors. So you see shallow closest to the trench, then they get gradually deeper inland. Do you see that?
Mhm.
So
Yeah.
they're following the subducting plate. So if you imagine a subducting plate beneath South America, it's curving down into the mantle here. So those deep earthquakes are happening. They're still on the same plate as these shallow earthquakes. It's just on, they're curved down beneath the continent there.
Yeah.
So this is a pattern. This one is asymmetric, right? Because it only goes in one direction.
Okay. Mm-hmm.
Here, like these guys are, I don't know, I'd probably describe them as fairly symmetrical about the mid-ocean ridges. It's a little bit hard to tell. Like we can look at the Juan de Fuca plate too. So yeah, it's a little bit hard to tell. Just describe what you see. You can see shallow earthquakes lined up along the mid-ocean ridge. That's one feature.
Yeah.
And, here's another subduction zone and trench. So do you see the same pattern we saw in the Andes?
Yeah. Similar.
Yeah, so shallow, closest to the trench, deeper, further from the trench on
Yeah.
the side. Yeah, there it is again. So here, this looks a little bit different, doesn't it? It's spread out more. So what do you think the difference is between this spot and down here where it's not spread out? You have a guess?
No.
All right, think about, do a mental experiment, because the Pacific plate is diving down beneath these plates, beneath North America over here and Asia over here, right?
Mm-hmm.
So use your hands if you need to, and imagine the earthquakes being along the subducting hand. If it's really steep, can you see my hands?
Yeah.
If it's really steep, then the earthquakes are going to be over a fairly small geographic area, right? But
Yeah.
if it's shallow, then look what happens to where the earthquakes go. It might be spread out further beneath the continent. So I would guess that that the plate is dipping pretty shallowly here beneath North America. So it's takes longer. You have to go further inland to reach those deep earthquakes.
Okay. Yeah, that makes sense.
Yeah, okay, good. So same, this looks like a steeper subduction zone because it's over a shorter space.
Mm.
But it's roughly the same pattern. I mean, there are a few oddballs, right? There's some shallow ones over there. But broadly, you see that same pattern. Here's that same pattern again, shallow to deep. Okay.
Okay.
There are, if we look at a continent collision like India and Asia, you don't see those deep earthquakes. Yeah, there are a few like here and there, but this is like a special, that one's an odd, that's kind of special. But here, it's all pretty shallow. So you don't have earthquakes following a subducting plate that goes really deep into the mantle. That's the whole point. So here it's kind of a shallow subduction because it's one buoyant continental plate underneath another buoyant continental plate. Here's another mid-ocean ridge. So this one you can see pretty well how the ridge actually spreads out from the center axis. So you can see the mountains going down that way and that way. And the earthquakes are right in the middle. So they're in the middle of the mid-ocean ridge, and they seem to be mostly symmetrical. Some, yeah, they're mostly symmetrical across those ridges. That's the kind of pattern that I'm asking about.
Okay.
And hopefully you can talk about all three plate boundary types and do the same kind of thing. So if you're going to do that, then like look at the San Andreas as another example. What would you say about the earthquake pattern with the San Andreas?
Put me on the spot. No.
So
Let me see.
just describe what you see. You won't be wrong if you describe what you see. So you want to describe what you're seeing along the San Andreas. So that goes from here, the top of the Gulf, and follows this way to here. That's the San Andreas. So now tell me what you see in the earthquakes.
The majority are shallow, if
Yeah.
not all.
Yeah. And what else? Look at the size of the circle is another thing that you can describe. So look, the very smallest circles are magnitude 1 to the largest circles are like magnitude 6, 7 or something. But so what do you see as far as the sizes are concerned?
The magnitudes are larger, closer to the main, like the coast.
Okay. Okay. What about like the whole range of magnitudes that you see?
It varies from like 1 to like the largest.
Well, yeah, maybe to like 6 or 7. I don't see any of the really large, the big ones. That okay, so if you hover, you can see that's a 7.2.
Okay.
That's the largest one there. There's a 7.1. Okay, so they go up to 7.
Okay.
So you can describe they're from magnitude 1 to magnitude 7. And what about the distribution? Like they follow they mostly follow the fault, right?
Yeah.
There are some other earthquakes that might not be related to the San Andreas too, but they're lining up along the fault, and yeah, I guess I would stop
Yeah, they
there.
occur there.
Yeah, so don't forget, like when you're talking about mid-ocean ridges, you should describe the magnitudes there too, and also for the subduction zone trenches. So not just the spatial pattern, like how far they're spread out.
Okay.
You want to represent the depth and the size of the earthquakes.
Yeah, that helps a lot because I wasn't describing the actual magnitude. I
Yeah.
did, but not really.
Yeah. Well, you've got a lot of information here, and it's hard to kind of like summarize it all. And it looks kind of messy to start with until you focus on a particular area. So I would pick a couple examples, like maybe South America is one example. Pick the example of each plate boundary type that is easiest for you to see a pattern in.
Okay.
Okay, does that help?
Yeah, it does. Thank you.
Awesome.
I had another question. It's for the plate boundary models.
Okay.
It's not the question in specific, but in the instructions it says that when you click on the plate boundary model layer, you turn it on. There should be like a plus or an arrow, so you can turn on the legend, but I don't see it.
The ledge. Oh,
Because
where?
I can't find it.
To show plate directions, is that what you mean?
I think so. It just said legend. It wasn't really specific, so.
Legend either. I wonder. Here, I'm going to right click on this and see if it gives us any information.
Okay.
Not there. What else did it offer me? Snapshot view. What is that? No, nothing. That's not going to help. Huh. I might have to investigate that and get back to you.
Yeah, because I was trying to do this and I was so confused. I was like, because when I it said press on the arrow, so I did, but the only thing that shows up for me is the plate boundary model, the plate boundaries folder, and then the plate labels.
Oh, I see what you're
But
saying. Yeah, to expand this. I see.
but it only shows for each option like just like where the plates are, like which ones I
Yeah,
want to display.
doesn't give you anything else.
Yeah.
Oh, here we go. I expanded that one. Okay, wait. Maybe we're getting there. Plate. Okay, so this is plate
Oh,
boundaries. This is plate labels. Okay. Origin outlines, that's all turned on. That's all turned on. All right, I'm gonna read the instruction next because I don't
so
see.
you have way more folders than me. I only have the
Oh,
the plate boundaries and plate labels, but not the rest.
okay.
Oh, never. What?
There were two there. There were two there. So I just,
Okay.
the,
Let's take a peek. Maybe I'm opening the wrong one. I don't know.
where is it hidden? Okay, which question was this so that I can read
This
the,
is question 13, under 12, basically.
okay. Unclick all of the layers, then click plate boundary. All right, then click the box to show it, and then click the plus or arrow to expand the legend. This shows plate boundaries and the names of major plates. Oh, that's all it is just, oh, that's all this is here. So that you can turn on the labels for the plate boundaries.
Oh, wait, that's it?
Yeah,
Oh,
that's
I
all.
was expecting like a legend like the earthquake
No,
one.
just to expand the legend here. That's all. It
Oh,
shows the plate boundaries and the names of the major plates. So I
bit
guess
my
that
nose.
I don't think that was turned on to start the plate names. So you can turn that on to just see it.
Okay, my bad.
Yeah, I'm
Thought
pretty
it
sure
was
that,
something else.
don't worry about it. It's easy to misread instructions in something like this, especially if there's no one else to like check your work against.
Yeah. Then
Yeah, I think that's all. Any other questions?
I think that's all.
Okay, you can take a
Mhm.
minute and peruse your lab if you need to figure out if there's more.
Yeah, I'm just quickly checking, double checking. Oh, for number 12 on the volcanoes.
Sorry, which number? 12?
Mm-hmm. 12.
Okay. So it says leave certain earthquakes on and then click the volcanoes layer. Okay.
Mhm.
So I'm going to go do that. So it says magnitude 1, 2.5, and 5 plus. It says all those basically. 1, 2.5, 5 plus, and then I want volcanoes. There we go. Is this the right one or is it this one? Okay. I downloaded a bunch of other stuff. I was experimenting with a bunch of different things. Okay.
All right.
So I don't, wait, where are the volcanoes? They're there in the little red triangles, aren't they?
Mm-hmm. Yeah.
All right. So what's the question?
Describe the relationship between the locations of most active volcanoes and locations of earthquakes.
I bet you can do this one now
I said,
after we talked about some like the earthquakes. So look at where the trench is.
Mhm.
Look at where the edge of the continent is. Look at where the volcanoes are. Now compare that to the earthquakes, the shallow earthquakes closest to the trench, and then they get deeper. So the volcanoes are over a deeper part of the plate.
Yeah.
As it's being subducted, right?
Mhm.
So just describe the volcanoes as being inland from the edge of the continent a little bit. You can even measure how far, right? Take your ruler and just like measure from the edge of the continent to the volcanoes 132 miles, or from the trench to the volcanoes. Wait, I don't think I drew a line just then. Trench to the volcanoes, 224 miles. So it's a ways in. It's fairly far inland.
Yeah.
So that's
Yeah, because all I had written before was just that they occur over volcanoes, and that's very vague.
yeah, that's too vague. So I want you to see that there's another pattern here, and that the subduction starts out in the ocean and the trenches forming there. That's where that subducting crust goes, starts to dive into the mantle. And then you see that pattern of increasing depth of the earthquakes. And the volcanoes are quite a ways inland, like 200 plus miles inland from the trench.
Mhm. Yeah.
So that means that the melting doesn't, I mean, part of how you're supposed to like think about this is like the melting doesn't start on the subducting plate until you get pretty far down, right? You're down between I mean, if you look, they're under the green earthquakes, or the
Yeah.
volcanoes are above the green earthquakes. So it's above the part of the plate that's between 70 and 150 kilometers down. So that means that the melting, all the water that's being dragged down with the plate, that melting process doesn't start until fairly deep.
Yeah. Okay, yeah.
And then it finds its way up to the volcano at the surface. Yeah.
Mm-hmm. Yeah.
So that was some of what you're supposed to see. You know, there's going to be a different pattern in the mid-ocean ridges compared to the volcanoes, right?
Yeah.
And there's no plate boundary here at all, but there are volcanoes and earthquakes. So that's something else to notice. You could say the same, you know, because it's a hot spot in
Yeah,
Hawaii.
for sure.
Or you could do the same thing with Yellowstone. So there's like Yellowstone volcanoes and some shallow earthquakes there. I see that there's some like borders and things that might be like getting in the way there, but they're the volcanoes. So depending on what the question is asking, let's see, describe the relationship between locations of, so it doesn't say one particular place. So what I would do is I would, again, make sure you cover all 3 plate boundary types, and maybe you want to add hotspots in there too.
Okay.
So there's going to be a different pattern for each one.
All
and
right.
then just go one by one, find a nice example of each one, and then describe what you see.
Okay.
Okay?
All right.
Just
Appreciate it.
include as much detail as you can so that you're making sure you have a complete answer.
Yeah.
Okay?
Thank you. I appreciate it.
You're welcome. Good luck.
All right. Have a good one. Oh, one last question. Last week's lab, I turned it at 1 minute late.
Oh, which one? The
Dating.
dating? I haven't graded those yet, so you're good.
Okay.
And
Literally 1 minute.
I'm really tight on those deadlines. I'm gonna like really hold you to that. No, that's not my style, so don't worry about it. But
All
thank
right, thank you. All right. Have a good one. Take care.
All right. Good luck. Bye.
Thank you.